Welcome. It's my second keynote here, so it's good to be back. Hopefully some familiar faces. Who was here last year? Awesome. Who's coming back next year? Hopefully me, please. Oh, before I forget, is there a timer? Yes. Okay, cool. So, a little bit of a different talk from me today. I usually talk about state management or architecture or Angular things. So I want to touch on some TypeScript concepts, which I think are really cool. They're quite beneficial. So before we dive into the things that we all want to learn, if you've got any questions afterwards, you can recognize me standing like this, if that makes it easier. Most people recognize me by my hair. So I run Ultimate Angular, which is now Ultimate Courses, where I basically make training materials for developers such as yourselves. So we'll just jump straight in. So I want to talk about generics and type queries, things like type of and key of, things that when you open somebody else's TypeScript file, you look at and yikes. So we want to kind of help understand some of the more advanced features. And they look very simple, but they give you really beneficial things. And then we'll have a look at map types. So let's start with generics. Generics allow us to create reusable components. And by components, I don't mean Angular components, just generic reusable pieces of code, units or classes or things like this. Generics allow us to have a variety of types. So let's go ahead and explore what we can actually do with these. So if anybody knows me, I'd like to make apps with pizzas. So there'll be a pizza theme today. So let's assume that we've got a class called pizza, just some simple constructor with some private variables. And let's assume that we now have some kind of list. We all deal with objects, arrays, and these types of things. Now, at the moment, I'm hard coding my pizza array as private list of type pizza. When I add an item to this list, we can then accept that pizza as an argument. So this is really good in this respect. So we can say const list, create a new instance, and then I can call my method, and everything is perfect. But as you can see, class list, it sounds generic. We could call it pizza list, and then we'd have to duplicate it for user list or dashboard or email list or these types of things. And if we wanted to do something like this, where we created a new instance of the list, we can say, I want the user list to add an item, and I've got another class hanging around in my code, where I say, I want to create a new user. So my list doesn't do anything magical, it just allows me to manipulate an array. Now, what we can do, because we want to make this generic and we want to keep this type safety, is use a generic. So taking our initial class, we can have class list, and keep an eye on these pizza words. Hopefully pizzas don't form in your eyes. But keep an eye on the pizzas, and then we can see that we can switch this to the letter T. So I'll just flick back again if you didn't see it. So what this means is this is kind of a placeholder type. So we have this angled brackets. I think that's where the name Angular came from. It was genius. So we've got these angled things here with the T inside. Now, if you've seen these before and don't know what they do, pay attention. If you've seen them before, don't fall asleep. So we can essentially say that we've got it's kind of a dynamic variable that you can think of it as. So we're going to say my list is of type dynamic variable and an array. And then when I add an item, that's going to then be just one of whatever it is that's dynamic. Now, because we've had this pizza class before, we can say new list, and this is how we can supply the specific type definition to this particular list. So we're tying the two together. Now, when you hover over things in the text editor, so if we hovered over list here, this would give us this type definition. So it's inferring this type that we are specifying here when we invoke a new instance of the list and passing things down. So this T will go to here and anywhere else that you're using inside the code. So you can see here we have pizza. Now the really good thing is this is now a more generic style list. So we can say we have a new list and we're going to say the type is going to be pizza. This list will be of type user, which can be another class, and we can go ahead and start using these add item, and they work perfectly. We don't want any red underlines, essentially. So that was kind of a precursor to some of the type query things, because some of these link together, these features. So type queries are kind of small but powerful. They're kind of interesting little things. So we can use the typeOf operator to capture what we can call an anonymous type. We'll have a look at this. Now, JavaScript itself has typeOf, which we know isn't very reliable. And the TypeScript version of typeOf is not the same as JavaScript's typeOf. So if you see typeOf being used in a type definition, it's probably TypeScript, not JavaScript. So let's assume that we have a const of person. Now, what I like to do for this example is just say that this might be hard-coded somewhere, or it might be coming from a function argument, and we might not have access to the type definitions, but we can see clearly that this is going to be a string and this is going to be a number. These are just simple examples so you can understand them. Now, you can see here, we're going to say, okay, because we don't have a type definition or it's hard-coded somewhere, we can say we're going to create our own type. We can say type person is the result of a type of person. Now, what this will essentially do is steal some information and give it back to us. So once we've stolen that piece of information, you can hover over your person type in your text editor, VS Code, hopefully, and it will look something like this. So TypeScript's clever enough to say, okay, we have a name property, which is of type string, and we have age of type number. And we can go ahead and lift these. So what this allows us to then do is, okay, we have a very sensible type definition somewhere in our code base now. So when we go ahead and create new users, we can now have that type safety. And it's a simple one-liner, type of person, and it will give you a lot of information. This does get cooler. So key of is very clever, and it's probably the coolest one of the two, so we'll save it for last. So we have these things called union types, and using key of, it allows us to capture the object keys and we get given a union type. So I've actually aged since the first slide where I was 27, but I'm actually 28 now. So here we have name string, then we have age is also number. Now, the piece that we just looked at was here. So we said type of person gives us a new type reference where we have name is type string, and then age is number. Now, underneath, we can take this one step further with this key of, and we can say, give me the key of the person type. So this is just, it looks like an interface at this point. It's just our own sort of custom type. So we have the keys, which it looks like an object. So the keys are name and age. So when we say, give me the key of the person, this new type of person keys will actually be a union type of both of those keys, so name or age. And you can think of use cases for this where you could have a function where you want to either add a name or an age, and you can do something conditional inside of there, perhaps. So this is actually a really, really cool feature, and it's interesting how TypeScript does this. So taking the knowledge that we have this type of person at the top, and then we have this key of, so we understand that now we have our own type, name and string, name and string, age is number, and we get this union type underneath here. Now the next step, if you look at our person up here, we then can pass these person keys, kind of like how you'd look up a property on an object, and instead of giving us name and age, it actually it's a reverse lookup, so it gives us the string and the number as a union type. So instead of giving us the keys, it's giving us the values. You can intertwine these, you can compose them how you like, so they're it's quick and easy, and they're really, really useful. Now for the really cool part. So when I first started using TypeScript, I would open up people's code and have no idea what was going on inside. So I kind of learned some of these cool techniques and extends, and these are probably my favorite slides of these. So we'll call them key of lookup types, and we use them with the generics. So that's why I've showed you generics to begin with. So there we go. So we know we have this type of person. That's nice and easy now. And we're going to have this person object, which has that name and age property. Now let's say we wrap this in a function. This could be a utility function inside a library or your own code base. So we have this getProp. Now I can see immediately that there's kind of an issue with this. So we're saying that we're passing in the person object, and I want the age property. Now there's nothing at the moment because we're saying this key is a string. So I could spell something wrong here, and TypeScript is fine with this, but there's going to be an error. Now the other problem is the type of this is any. So the return type isn't being inferred down to us. And you can see the return type will be based off of the object with the key lookup. So that's going to give us the value. So we can take it one step further. We can, now that we've learned the idea behind generics, we could say that we want to pass the type of person in. We can then have this t variable, and this will automatically pick up because we put this person here. But we still have the problem of we could spell this incorrectly, and we also have a type of any. Now, this is the funky piece of code, which, if you haven't seen before, it looks more complex than it is. So we'll explain this momentarily. So here, the idea behind this is that we get a reverse lookup. So you can see here we have number. So how do we get that piece of information? Now, if you think back a few slides where we had person, square bracket, person keys, we got given name, string, and number as a union type. Now, for one thing, t here is our generic variable. I'm not actually passing it in here, but we can pretend that we did this. Now, age is now a string. So age, name and age both live on our object property, and this second argument here is key, which we've given another generic variable name of k. So let's have a look at this piece, because this is the scary-looking piece. So we're essentially saying, and we're merging a generic with the key of lookup. So key of will return us name or age, because it's key of t, so we're getting both of the name and age properties. And we're saying k extends it, which is essentially I am a subtype of one of these. Now, what this means is cleverly, when we type in this piece here of age, it needs to then conform to either k's variable, in a sense. So it has to be name or age, which means if we spell something incorrectly, that red line is going to appear straight away. Now, the really, really cool thing is because we're using this reverse lookup, where we have name or age, but we can also, TypeScript can cleverly infer the value as well. So we had string and number. We then have person name is not of type any anymore, so it's of type number. So this is really powerful, and once you get your head around the syntax, you have to sometimes remember it when you look back at it, but it works. I've just put XYZ in there. If you type something wrong, we have a nice error. So, who's heard of map types? One person. I don't believe you. So, map types, we can essentially kind of think of this as a for loop or a map.map, array mapping, but for creating types based off of existing types. So let's say we have an interface of person. It's name, string, age, number, nice and easy, and we then simply bind this to our constant. Now, if we had a method which, in this case, I'm sure you can think of a real use case example with your own code bases, and we want to just immutably update an object property. So here we're going to say, I will pass in this person object, and I want to change the name property to ABC. Now, what this would actually do is give us an undetected error. So I could say name ZZZ, and this would happen because we have this key, string, and any. So if you are using this, this could be a new, a safer way to use typings. So we can abandon this approach. So if we introduce this thing called a partial, so this is fairly new to TypeScript, what it allows us to do is essentially take that person interface. So let me just flick back to here. We have name and age. And what it essentially allows us to do is say, this property is going to be a partial of person. So it could be one property, it could be 2 or 3 properties. Obviously, we only have 2 on the actual person interface, but in a real bigger interface, you could have a lot more. So what partial will do is make things optional. So instead of saying we want a key of string of any, which will allow us to spell things wrong, and we end up with errors, because it has to be one of the properties of person and it has to be spelt correctly, we can then pick up on anything that we spell incorrectly. So again, this is a really useful feature. Now, if you wanted to, when you use partial, for example, you can command click, it take you through to the type definitions, and you'll end up with something that looks like this. So this was another thing that I looked at and was like, oh, this looks a bit strange. So we already know generics, so we know that this is a placeholder for a special type. So T is going to be here. We know key of will return us the keys. So in our case, where we're using partial and person, we've got name and age. In this case, we're saying, give me a key of T. And this is kind of like a loop. So I mentioned like an array prototype map, for example. So this is a type mapping over those keys. So this variable becomes P, so we can say P in key of T. So this would be a union type, 2 items, and then we have loop. Now, because our initial interface, you can see here that there's no question marks. So this means that if we, for example, down here, forgot to add age, TypeScript would say, hey, you've forgot to add the age property. This question mark here essentially maps over an existing type and marks every single one of them as optional. So this is really clever. And I've basically explained it already. Cool. So there's a couple more map types which we'll just kind of gloss over because I think they're worth exploring. And I think you can save a lot of your code base time and effort by using these map types. Now, instead of our partial, let's assume that we want to make something read-only. So it might be that, if I go back a sec. So instead of a question mark here, we're saying every single property here must be of type read-only. So we're prefixing it with that. And all this piece is doing is iterating and then copying those variables across. Now, if we had some kind of freeze function, we could have object.freeze and return a frozen copy of that object. Now, if you look at the typing definitions for object.freeze, you'll actually see that it uses this read-only, and it's using the generic type. So cleverly, TypeScript can pick up what type of your object is through this generic, and then pass it down another layer where we have this T here. And what that means is the return value of this freeze person function, you can see here we have a read-only with a generic type of person. So all this information flows down nicely for you. A few more examples which are worth using, or at least looking at. Another example, if you want to stringify something, you could just map over it. This could be for JSON storage or local storage, something like this. So it converts everything to a string. There's not much else stringify does. If you wanted to make something nullable, you can again go ahead and iterate over properties of an interface or a type, and then just allow it to be somewhat nullable. We also have record. So what this would essentially do is allow us to set some kind of string value. So when it extends string, the first argument must be of type string. So you can kind of think of it as a key value pairs. This one's pretty good. I like pick. It's kind of like a pluck. So in this case, it looks quite similar to partial, but it's you specifying, I want these properties. I don't care about any other properties. So here we've got our interface with name, age, and address. And now, for some reason down here, I don't care about the address, but I want to make sure I can reuse my interface. I don't want 5 different interfaces with one line deleted out of each one to make a slight adjusted version. So here I can say, I want to pick some properties from my person interface, and I just use this pipe to separate the properties. So I can say, I want to use name and age, and voila, we can name an age. So how did we do on time? I think that was quite quick. But so yeah, thank you for listening. If those topics are quite handy for you, I've built this coupon for everybody if you want to take a photo. Thank you. So I do a lot of Angular training. We've just released some JavaScript training as well. So that will give anyone who's interested 20% off. So thank you very much for listening.